Hi everyone, welcome to My Max Academy. In this video, we will continue with the chapter Determinants from your 12th standard CBSE Mathematics. I am going to continue with miscellaneous exercise, page number 139. Page number 139, problem number 33. Example 33. It says use the product of these two matrices to solve the system of equations. So we have to use the product of these two to solve this. We have to solve this and find x, y and z. So which means let's try to find the product of this. So we need to multiply these two. So which means solution is let's multiply this. 1 minus 1 2 0 2 minus 3 3 minus 2 4 into minus 2 0 1 9 2 minus 3 6 1 minus 2. If you multiply them, so what do we get? So 1 into minus 2 is minus 2, minus 1 into 9 is minus 9, 2 into 6 is 12, and minus 1 into 0 is 0, minus 1 to 2 is minus 2, 2 into 1 is 2, then 1 into minus 1 is minus 1, this is plus 3 and this is minus 4. Fine, then 0 into minus 2 is 0, 2 into 9 is 18, plus then minus 3 into 6 is minus 18. Again second row with second column, 0 into 0 0, plus 2 into 2 is 4, minus 3 into 1 is minus 3, then 0 into 1 is 0, plus 2 into minus 3 is minus 6, plus minus 3 into plus 2 is plus 6, then 3 into minus 2 is minus 6, minus 2 into 9 is minus 18, 4 into 6 is 24. Then 3 into 0 is 0, minus 2 into 2 is minus 4, plus 4 into 1 is 4, 3 into 0, 0 into 1 is 3, minus 2 into minus 3 is plus 6, 4 into 2 is minus 8. That becomes, this is 11 plus, minus 11 plus 12 is 1, 0, 0, then this is 0, 1, 0, 0, 0, and 9 minus 8 is 1. So what we got? When you multiply these two matrices, we got the identity matrix I. So which means the inverse of this matrix is this or vice versa. So if you multiply two matrices and we got identity matrices, then this, the inverse of this matrix is this or inverse of this is this. Right? So we can say inverse of this is equal to, so we can say therefore we can say, therefore if you take this matrix 1 minus 1 2 0 2 minus 3 3 minus 2 4 whole inverse is equal to this matrix, which is minus 2 0 1 9 2 minus 3 6 1 minus 2. This is inverse of this matrix is this. Suppose if we call this as A matrix, right, then A inverse. Suppose if we call this as this matrix as A matrix, suppose if we call it as A matrix, this is like A inverse. A inverse is this, which is equal to this, and this is your A matrix. So this is A inverse. Right? So now let's take, now we have to solve this equation. So we found the product of the two matrices, the identity matrix. Therefore we said this is an inverse of this, or we can also say this is the inverse of this. But there is a reason why I say this inverse of this is this. Because if you observe this matrix, the set of equations, and if you convert them as a matrix equation, then we can have A matrix. If you observe the A matrix, which we are calling it as A, it's same as the coefficients. This matrix is coefficient 1 minus 1 2 is here, and 0 2 minus 3 is here, and 3 minus 2 4 is here. So the coefficient of this matrix is the matrix A, 1 minus 1 2, then 0 2 minus 3, then 3 minus 2 4, and our X matrix capital X will become small x y z, and our B matrix is equal to this one 1 1 2. So the given set of equations, this will become like Ax equal to B, A into X equal to B. So if you multiply these two and if you equate it to this, then you will get this into this, x minus y plus 2z. 2 into 2z equal to 1. Then 0 into x is 0, 2 into y is 2y minus 3z. 3 into z. 3z is 1, which is this. Similarly, 3 into x minus 2 into y plus 4 into z is equal to 2. So, what is our x? Our x is A inverse B. Our x is A inverse B. Right? So, now what is our A inverse? The A inverse is given. A inverse is, so x equal to A inverse. A inverse is what? This matrix. This is the inverse of this matrix. Is this? So that is A inverse is minus 2. We don't have to find the A inverse. In this question, we see that the inverse is given because product of these two gives me 1. Therefore, the inverse of this matrix is this. So minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2. A inverse into B. B is 1, 1, 2. So A inverse is this, B is this. A inverse is inverse of this. Inverse of this is this matrix. This is A inverse. So I'm substituting that A inverse here into B. So if you multiply this, what do we get? X is equal to minus 2 into 1 is minus 2, 0 into 1 is 0, 1 into 2 is 2. Fine. Then again if you multiply, 9 into 1 is 9, plus 2 into 1 is 2, 3 into minus 6. And 6 into 1 is 6, plus 1 into 1 is 1, minus 2 into plus 2 is minus 4. So your X matrix becomes 0, this becomes 11 minus 6 is 5, 7 minus 4 is 3. So what we got? Our matrix says 0, 5, 3. So this X is what? Your X is small y, x, y, z. This is your capital X matrix. That is equal to 0, 5, 3, which means your x is equal to 0, your y is equal to 5, and your z is equal to 3. So that is your solution. So x is 0, y is 5, and z is 3. So if you substitute here, you will get this. If you put 0, x is equal to 0, 0 minus 5 plus 2 times 3 is 6, minus 5 plus 6 is 1. Again here if you substitute 2 times 5 is 10, 10 minus 3 into 3 is 9, which is 1. Again 3 into 0 is 0, minus 2 into 5 is minus 10, plus 4 3s are 12, so 10 minus 12 is 2. So this is the solution of given set of equations. Fine. So all of you can pause the video and take the notes. I'll go to the next example, which is example 34. So example 34 is, we have to prove that. So PT, prove that delta equal to determinant of a plus bx, c plus dx, p plus qx, then ax plus b, cx plus d, and px plus q, u, v and w. This is equal to, we should prove it as 1 minus x square into determinant of a, c, p, determinant ACP, BD, Q, U, V and W. You are sure that the value of this is equal to, fine. Now, so how do we do this? Now, again, we will have to somehow take this 1 minus x square term here. We have to get this 1 minus x square term here. Now, how can we get 1 minus x square term? Suppose, if you observe here, if I multiply this with x, the second row with x, this will become ax square, and this will become bx. And then if I subtract r1, if I subtract this from r1, after multiplying by x, r2, if I subtract it from r1, I will get a plus bx minus x into this. That will become ax square minus bx. Then plus bx minus bx will get cancelled. I will get a minus ax square. And a, if I take common, I will get 1 minus x square. Similarly, here also I will get c into 1 minus x square. Here also I will get p into 1 minus x square. So what we can do is solution. I'm going to apply here. So delta equal to, directly I'm applying here from the LHS. So LHS. Delta S, I'm going to say R1 implies R1 minus x times R2. So which means a plus bx minus x into ax plus b. So if I do that here as a rough calculation, a plus bx minus x into ax plus b will give you what? A plus bx minus ax square minus bx. So plus bx minus bx, you can get a into 1 minus x square. So this will become a into 1 minus x square. If you do this, r1 minus x times r. Similarly, this will become c into 1 minus x square. If you do this minus x into this. Similarly, this minus x into this will give you p into 1 minus x square. Fine. This is your rough work. I just showed you how this is coming. I'm erasing this. I just showed you how this a into 1 minus x square comes. So similarly, this will become p into 1 minus x square. Close the determinant. So other two will write as it is. ax plus b, cx plus d, then px plus q. And third row, no change. Now again, if we observe here, so delta equal to here 1 minus x square is common in the first row, right? So we can take 1 by x square out. So 1 minus x square, if it comes out, we will have a, c and p. This will be ax plus b, cx plus d, px plus q. Fine. So I'll put this little bigger so that cc. So a, c and p will become cx plus d. This is px plus q, u, v and w. Fine. So now what we get is, so delta is 1 minus x square into, now okay, let's observe. Now 1 minus x square has come out. We have acp, we have uvw. Now this we have to somehow get vdq. So how do I get this here b alone? I can get here b alone if I do this minus x times this. So ax plus b minus x times a will give you minus ax. So they will get cancelled. You will get only b here. So similarly here you will get d, here you will get q. So the operation that we can do is r2 implies r2 minus x into r1. R2 is ax plus b minus x into a. So ax plus b minus xa. Ax will go, you will get b alone here. So your delta will become 1 minus x square into the row, first row no change. Second row will come ax plus b minus x into a will give you b. Then cx plus b minus x into c is minus xc plus xc, which will cancel, you get d. Similarly here you will get q, and the third row no change, uvw determinant. So which is your RHS. So acp, vdq, uvw, 1 minus x square times. So that is equal. So we have proved that the delta, which is value of this, the delta equal to this. Right? So this is the end of this problem. So all of you can pause the video and take the notes. I will stop the session here. You can watch my next session for the continuation of this chapter. Thank you for watching. See you all in the next video. Thank you.